Hi. Now let's today solve an equation that'll require the use of the so-called W Lambert function. The W Lambert function is denoted capital W, and capital W of x e to the x will equal x. And we're going to restrict ourselves to the principal branch of the Lambert function, and that is denoted W sub 0. And it is well known that W sub 0 of z will be real if z is greater than or equal to minus 1 over e. And the equation we want to solve today, it looks kind of gnarly. We want to solve for y. The equation reads y equals a, which is some constant we don't know yet, times the natural log of y. And we're going to determine what possible a's we can put in there in order that the w function will be real. And so let's solve this. The first thing I think we should do would be to divide by a and divide by y. So right off the bat, we know that a cannot be 0. And like I said, we also want a to be a real number. Okay, let's do that then. Well, this will leave us 1 over y times the log of y equals 1 over a. Now, next step, let's use the properties of the logarithm to pull a minus 1 out. So minus 1 over y log of now 1 over y equals 1 over a. Okay, let's move that negative sign to the other side. This will leave us 1 over y log of 1 over y equals minus 1 over a. Okay, we're getting close. We're getting close. Now let's change this 1 over y into something that is equal to that, but let's turn it into e to the log of 1 over y. And at the same time, bringing the log of 1 over y out front will leave us log of 1 over y e to the log of 1 over y, of course, still equals minus 1 over a. So now we can see we're getting it into the proper form. Notice we have something e to the something. As up here, we have x e to the x. So this seems to suggest we can apply the Lambert function, actually the principal branch of it. So let's do that. W0 of log of 1 over y e to the log 1 over y equals W0 of minus 1 over a. Of course, we had to do that to both sides of the equation. Okay, but now using the property of the W function, we know that W0 of blob e to the blob is just going to be blob. So here we'll have log of 1 over y equals W0 of minus 1 over a. Okay, now it's time to determine what a's we can use, what a's that are real that we can use that will make W0 of it a real number. So let's go up here. We know for that to be true that this number, z, has to be greater than or equal to minus 1 over e. Z in this case, of course, is our minus 1 over a. So we set minus 1 over a is greater than or equal to minus 1 over e. Well, of course, there are two cases. We've already eliminated a equals 0, obviously. But case 1 will be if we wanted a to be less than 0. So up here in our determining inequality, let's get rid of the minus sign. Since it's a minus, we have to flip the sign. So we'll have 1 over a is less than or equal to 1 over e. Now I want to cross multiply. Well, since a is less than 0, when we cross multiply, we have to flip the sign again. And this will leave us a is less than or equal to e, which implies we have two restrictions now. A less than 0, a less than or equal to e. The intersections of those two requirements implies that a is less than 0. All right, very good. Let's look at case 2, where a is greater than 0. Again, we start off by eliminating the negative sign, and we get 1 over a is less than or equal to 1 over e once again. But now this time, a is greater than 0, so we don't flip the sign when we cross multiply. And this will leave us a is greater than or equal to e. Now we have two restrictions again, a greater than 0 and a greater than or equal to e. The intersections of those two requirements will imply that a must be greater than or equal to e. Therefore, in conclusion, if we want a real solution to our problem, a must be a member of the set minus infinity to 0, not including 0, union e to infinity, including e. Very good. Well, that'll give us all our possible a's that we can use. So down here, let's go back down here. We ended up with log of 1 over y equals w0 of minus 1 over a. Let's exponentiate both sides. So 1 over y then is equal to e to the w0 of minus 1 over a. And now our final step is just to take reciprocals. So y equals e to the minus w0 of minus 1 over a. And as we have described, this will be real if a is a member of minus infinity to 0, union e to infinity, including e. And we have squashed the bug. We have solved the problem. And it really wasn't that hard. So, don't be intimidated by these, gnarly looking equations. Just because they're not polynomials doesn't mean we cannot solve them. And I'm sure you'll be able to solve any one like this when you come across it. And thank you so much for watching our video.